Welcome back to our last video on functional groups. So here we're going to go through some more practice with larger molecules of spotting all the functional groups. And remember in the past video that I was asking the question, are there any heteroatoms? And if so, what type? And it's very important that I go in the order of halogen, sulfur, nitrogen, and last focusing on that oxygen. Okay, so are there any heteroatoms? Well, of course there are in this example, but let's first check to see if we have any of those hydrocarbon groups. So here I'm just asking, are there any carbon-carbon double bonds, or are there any carbon-carbon single bonds? So, of course, a carbon-carbon triple bond. So, of course, we do see some carbon-carbon double bonds, and that gives us one of two options. It's either an alkene or an aromatic. Okay, and aromatics are those special things where we've got the carbon-carbon alternating carbon-carbon double single bonds in a six-membered ring. And we do indeed have that. Now, when you spot that aromatic, you're always wanting to double check that you don't have a phenyl, right? And a phenyl is where you have the OH group that's directly attached to that ring. And here, the OH group is not directly attached to the ring. It's attached to a carbon that's then attached to that ring. So this is not considered a phenyl, but instead, it's just an aromatic. Okay, so now those are the only carbon double or carbon triple bonds. So we're done with the hydrocarbon section, and next we look at the halogens. If I spot a halogen, that is my haloalkane. Okay, those are some of the easiest to spot because there's only one type and we don't have to ask any questions. Then we look for sulfurs, which I don't see any. And then next come the nitrogens. Okay, now the nitrogens, I do have one here. And I've got to look on both sides of that nitrogen and ask, do either one of those carbons have a carboxyl group, a double bonded oxygen? And they do not. So if they don't, that's my amine. Okay, and then last I'm going to look at those oxygens. So I have to ask, does the carbon have a single bonded oxygen, a double bonded oxygen, or does it have both? There's only one carbon over here that has only a single bonded oxygen with no double bonded oxygens. Okay, that could either be a phenyl, which we've already eliminated because it's not directly attached to the ring, or it's going to be an ether or an alcohol. So remember, if the oxygen has a hydrogen attached to it, that's an alcohol. Right, for it to be an ether, it would have had to have had a carbon coming off of both sides of that oxygen. And then the last thing, do we have a double bonded oxygen? We do, but it also, that carbon has a double and a single bonded oxygen. And so is it a carboxylic acid or is it an ester? So it is at the end of the carbon chain. That single bonded oxygen does not have a carbon coming off of both sides of it. And so that's our carboxylic acid. Right, an ester would have a carbon coming off of that oxygen on both sides. Okay, and that gets all of our functional groups. So let's try this again. Now, when I have a skeletal structure, I recommend going through and dotting all of the kinks, all of the ends of the lines, to make sure that I can spot all of the carbons. Okay, and remember with a triple bond, it's going to be on either side of that triple bond. Okay, and that way it's easier to tell when I'm at the end of a carbon chain. Okay, so remember we start up with the hydrocarbons. So we're looking, is there a carbon-carbon double bond? Is there a carbon-carbon triple bond? And we do see a carbon-carbon double bond right here. Okay, and it's not in a 6-membered ring. It's not alternating double and single. And so this has to be our alkene. And then we also have a carbon-carbon triple bond right here, and that would be our alkyne. Okay, and then again in that order, we're going to look for halogen, sulfur, nitrogen, and we don't see any of those in this compound, so we're down to the oxygens. And remember, with the oxygens, the first thing we're asking is, okay, does that carbon have only a single bonded oxygen? Does it have only a double, or does it have both? So we have 2 carbons. We have one here. And we also have one here. Okay, so the one on the right-hand side, that carbon is only a double bonded oxygen attached to it. So we know that it's either an aldehyde or a ketone. Remember, aldehydes are going to be at the end of a carbon chain, and so the fact that we have a carbon coming after that carbon on both sides means that this has to be a ketone. It's not considered at the end of the chain. Okay. And then the last one, we have that carbon that has both a double bonded and a single bonded oxygen. So here we have to ask if it is a carboxylic acid or an ester. And how we decide is by looking at that single bonded oxygen. Does it have a carbon on both sides of it? And because it does, that's our ester. Right up here where that oxygen had a hydrogen coming off on one side, that made it a carboxylic acid. Okay, last example. So again, we have a skeletal structure, which means that I'm going to go in and Christmas tree this with all the carbons at every kink and at the end of every line that doesn't show an atom. Right, so I don't put one here because that has a hydrogen shown. Okay, now I'm looking for my hydrocarbon. Remember, that's the carbon double bonds, carbon triple bonds. I do see one here. That's my aromatic. But remember that I have to ask, does it have an OH group directly attached to it? And in this case, it does. That oxygen is directly attached to that ring. And so instead of calling this an aromatic, we technically want to call this a phenol. Okay, I don't see any other carbon-carbon double or triple bonds. So then I look for the halogens. I don't see any, and there's no sulfurs. So next comes nitrogen. And when I look at the nitrogen, I've got to look at the carbon on either side and ask, do either one of those carbons have a double bonded oxygen? And this one does, right? So when we have a carbon that has a carboxyl group as well as that nitrogen, that's going to be our amide. And now last, we can focus on just the oxygens. So I see 2 other oxygens that haven't been accounted for. I've got this oxygen in the middle. Okay, and it is a single bonded, and neither one of the carbons that are attached to that oxygen has a double bonded oxygen. Okay, so we're looking at the single bonded oxygens, which are the phenyl, the ether, and the alcohol. Well, we know it's not part of the phenyl. We've already located that part. So whether it's an ether or an alcohol depends on if there are carbons on both sides. So because there's a carbon on both sides of that oxygen, that makes it an ether. Okay, and then the last one that we have is a double bonded oxygen, and the carbon attached to it does not have a single bonded oxygen. So if we're looking at only double bonded oxygens, it's either an aldehyde or a ketone. Remember, aldehydes come at the end of a carbon chain and ketones are buried somewhere within. Like this is our example of a ketone. But this time it's at the end of the carbon chain, and so it's an aldehyde. Just remember that carbon does have a hydrogen coming off of it. Okay, so this should wrap up our functional groups